Hello, Professor. This is the explanation of my homework 5 code. This is Max Carduner. So first, starting at the top, quadratic cost already done. Cross entropy cost, that was something that I wrote the derivative of. And that's below here. Then the log likelihood is also something that I did, written here. Then the sig for the activation functions, sigmoid was done for us. Softmax was not completed. Derivative was provided, but I wrote the function. And then ton, just a skeleton. So that one's pretty easy, just np ton, and the derivative is 1 minus np ton squared. And then I wrote this whole class ReLU, which just returns the maximum of either z or 0 for the array. And then the derivative is 0 if it's less than 0, and 1 if it's greater than 0. For the network, what I modified was to make sure that ton and quadratic cost were together. We didn't have to do that, but I decided to do that. And same thing for the hidden and outer layer. And the same thing for the set parameters. Didn't change that one, didn't change that one. So feed forward, I had to modify a bit in order to make the output activation function applied for the outer layer. So essentially x is the length of the weights, and then -1. And if c equals x, then that is the final layer that needs to be the final hidden layer that the output layer activation function needs to be applied to. Otherwise, then do the activation hidden. And of course, if it's the same function, then the act output is set as act hidden, so it doesn't really matter. So for SGD, didn't do anything here. This is all the same. So I'll skip that. Update mini batch. So just was going top down. The main thing that I edited here was the dropout percent, because we needed to create that mask vector prior to each mini batch. So what I did was I created it here, and I created a for the mask for each mini batch, the same mask, so that in each mini batch it applies the same mask function, so that when update mini batch is called, then that's when it's called. Then that backprop function is passed in with that that mask vector, which is here, right? And that is passed in now here. So that was the other modification to the backprop function. And backprop function, I guess first it has the same type of activation logic that the other activation that the feed forward code did, because you had to do that here as well. And then for the U, or the mask vector, that is if the self dropout percent is greater than 0, then that is multiplied by the mask vector for that layer. And then everything else is essentially the same there. Nothing has changed here. Accuracies, nothing has changed there. And then for total cost, implement L2 and L1. There is a parameter for equalization at the top, and it's set to either L2 or L1. And if it's set to L2, then it does this. That it calculates the L2. And then if not, it does the L1. And then if it doesn't have either, then it's just going to return cost. So all it's taking is that cost function and either shrinking all of it or only taking the max coefficients. So L1 shrinks all the coefficients that don't matter to 0 using kind of that absolute value, and the L2 regularization multiplies the same coefficient times every multiplies the lambda parameter by every coefficient, so that the all of the coefficients are decreased. So yeah, that's the only thing it changed in there. And then in the application code, here we have did the experiments that were ran, and they match to your results. So for 1 through 10. However, call out that I switched the test and the training set so that the training is here and the test is here, so that it matches your outputs. So it's easier for me to validate. So it's a slight switch from your starter code. But everything else is pretty much the same. I implemented these guys and got the results that matched yours. I guess the ones that I should talk about that won't necessarily match are the ones that include dropout, and that was in the ballpark of what yours had. So I figured that I did implement it correctly. But yeah, thanks for watching. That was a fun assignment. Thanks.